Ooh, it's so beautiful. No, it's not a Van Gogh, not even a Picasso. And yeah, it sort of looks like a metro map. This is a picture of what our application could look like if we leveraged the power of Angular modules. Instead of one large app module like we have now, there are multiple modules, and each piece of our application has a logical place within one of those modules. This keeps each module smaller and more manageable. In this course module, we take another look at the definition and purpose of an Angular module. We then focus in on the Angular module metadata to better understand how to use it. We leverage that knowledge to create a feature module for our application, and take it one step further, defining a shared module to reduce duplication. Lastly, we re-examine our application's root Angular module. Let's get started. What is an Angular module? As we've seen earlier in this course, an Angular module is a class with an NgModule Decorator. Its purpose? To organize the pieces of our application, arrange them into cohesive blocks of functionality, and extend our application with capabilities from external libraries. Angular modules provide the environment for resolving the directives and pipes in our components templates. We'll talk more about this in a few moments. And modules are a great way to selectively aggregate classes from other modules and re-export them in a consolidated convenience module. We'll create our own convenience module when we build a shared module a little later. An Angular module can be loaded eagerly when the application starts, or it can be lazy loaded asynchronously by the router. Lazy loading is out of the scope of this course, but is discussed in detail in my Angular routing course here on Pluralsight. How does an Angular module organize our application? An Angular module declares each component, directive, and pipe that it manages. Every component, directive, and pipe we create belongs to an Angular module. An Angular module bootstraps our root application component, defining the component needed to display our first template. An Angular module can export components, directives, pipes, and even other Angular modules, making them available for other modules to import and use. An Angular module imports other Angular modules. This brings in the exported functionality from those imported modules. Note that in this context, and throughout this module, when I say imports, I mean add it to the NgModule Decorator's imports array. I'm not referring to the import statement, though we also need to add an import statement for each module we add to the imports array. We can think of an Angular module as a box. Inside that box, we declare each of our components. If the templates for those components need any functionality, that functionality also needs to be defined within this box. The app component template sets up the routing for our main menu using router link and includes the router outlet directive. So the box needs the routing directives, router service, and routes, which are defined in router module. The product list component template uses NgModule, so the box needs the forms module. The product list component template uses ng-for and ng-if, so the box needs the browser module. The product list component template uses the convert to spaces pipe, so the box needs that too. The product list component template also uses the star rating directive, so that must also be in the box. And so on, until the box contains everything that each of our component templates need. Saying this another way, the Angular module provides a template resolution environment for each component that belongs to the module. It provides a way for the compiler to find and resolve the special Angular syntax we put into our HTML. We didn't need to think about template resolution much in our sample application up until now, because all of the pieces of our application are in one Angular module. But we will need to keep this in mind as we split our application into multiple Angular modules. Let's take a quick look at our current AppModule. Here is the Angular module we defined throughout this course, It is the application's root Angular module, and by convention is called AppModule. The AppModule imports the system Angular modules we need, including the router module, which is where we configured our routes. It declares each component and pipe that we created in this course, and it bootstraps the application with the root application component, app component. We have a lot of information in here, and we're mixing up basic application pieces, such as our welcome component, with pieces specific to our product feature. Let's journey through the NgModule metadata to better understand how Angular modules work, so we can then refactor our app module into multiple modules for better code organization. As we have seen, every Angular application has at least one Angular module, called the root application module or app module. And an Angular application has at least one component, called the root application component or app component. The app module bootstraps the app component to provide the directive used in the index.html file. We covered the bootstrapping process in the Introduction to Components module earlier in this course. The bootstrap array of the NgModule Decorator defines the component that is the starting point of the application. This is the component that is loaded when the application is launched. Here are some things to keep in mind when using the bootstrap array. Every application must bootstrap at least one component, the root application component. We do this by simply adding the root application component to the bootstrap array of the root application module. The bootstrap array should only be used in the root application module, AppModule. As we build other Angular modules, we won't use the bootstrap array. Every component, directive, and pipe we create is declared by an Angular module. We use the declarations array of the NgModule Decorator to define the components, directives, and pipes that belong to this Angular module. Here are some things to keep in mind when using the declarations array. Every component, directive, and pipe we create has to belong to one and only one Angular module. In our sample application, all of our components are defined in one Angular module, AppModule. It would be better to divide the components into multiple modules, with basic application pieces in the app module and feature pieces in appropriate feature modules. We'll do that a little later in this course module. As we separate out our pieces, it is important to remember that each component, directive, and pipe belongs to one and only one Angular module. Only declare components, directives, and pipes. Don't add other classes, services, or modules to the declarations array. All declared components, directives, and pipes are private by default. They are only accessible to other components, directives, and pipes declared in the same module. So if we declare the star component in module B, by default that component is not available to components in other Angular modules. We share components, directives, and pipes by exporting them. We'll talk more about exporting in a few moments. The Angular module provides the template resolution environment for its components templates. When we include a component in the declarations array of an Angular module, the component belongs to that Angular module. That component's template, directives, and pipes are then resolved within that module. When we use a directive in a component's template, Angular looks to the module for the definition of that directive. If the component defining that directive is not declared within the same Angular module or exported from an imported module, Angular won't find the directive and will generate an error. For this example, the star component must be declared in the same module as the product list component, or the star component must be exported from an imported module, never both. The exports array of the NgModule Decorator allows us to share an Angular module's components, directives, and pipes with other modules. We can export any of this module's components, directives, and pipes so they can be pulled in when another module imports this module using the imports array. We can also re-export system Angular modules, such as Forms module, We can re-export third-party modules, such as Material Design. Material Design is a set of high-quality user interface components, including buttons and dialogues. And we can re-export our own modules. Here are some things to keep in mind when using the exports array. Export any component directive or pipe if another component needs it. A module can export any of its declared components, directives, or pipes. Re-export modules to re-export their components, directives, and pipes. This is useful when consolidating features from multiple modules to build a convenience or shared module. We can export something without including it in the imports array. The imports array only needs to import the modules that are required by the components declared in the module. But the Angular module can still provide capabilities to other modules that import it by re-exporting. In this example, a shared module exports the Forms module, even though it did not include it in its imports array. So any module that adds shared module to its imports array will have access to the NgModule and other Forms directives. We'll see this in an upcoming demo. An Angular module can be extended by importing capabilities from other Angular modules using the imports array. Many Angular system libraries are Angular modules, such as the Forms module and HTTP client module we've used in this course. We can import Angular modules to use their capabilities. Many third-party libraries are also Angular modules, such as Material Design. We can import third-party Angular modules to use their capabilities. We can import our own modules to extend our application with additional features or share capabilities across several modules. We'll see that in an upcoming demo. Here are some things to keep in mind when using the imports array. Importing a module makes available any exported components, directives, and pipes from that module. Recall that we are using NgModule in our product list component for two-way binding. The NgModule directive is exported in the Forms module. By importing the Forms module into our AppModule, we can use NgModule in any component declared in our AppModule. Only import what this module needs. For each component declared in the module, add to the imports array what is needed by the components template. Importing a module does not provide access to its imported modules. Let's look at that with a picture. Here we have AppModule, which declares the product list component, and a shared module that declares and exports the star component. AppModule imports the shared module, so the shared module's exports are available to the AppModule's component templates. This means that the product list component can use the star component directive. If the shared module imports Forms module, then the Forms module's exports are available to the shared module, and the star component could use the NgModule directive. But the Forms module exports are not available to the AppModule, so the product list component could not use the NgModule directive. I've heard this rule also stated another way. Imports are not inherited. Note, however, that if the shared module re-exported the Forms module, then the Forms module exports are available to the AppModule, and the product list component could use the NgModule directive. Use the imports array to register services provided by Angular system modules, such as HTTP client module and routing module, or to register services from third-party modules. Normally, we add a module that registers a service to the imports array of the AppModule. This ensures that services are registered one time when the application is initialized. Angular modules can also register services for our application. We can use the providers array to register our services with the root application injector. However, this is no longer the recommended practice. Starting with Angular version 6, the recommended way to register our services is to use the provided-in property of the service itself. not the providers array of an Angular module. You may see older code use the providers array to register created services, but moving forward, use the services injectable decorator with provided end set to root to register the service with the root Angular injector. Now that we've covered the basics of the NgModule Decorator, let's refactor our application into multiple Angular modules. So far in this course, we've used the root application module, AppModule. It declares all of our components and our pipe. It imports the system Angular modules that our component templates need. But this is getting a little unwieldy. We have no separation of responsibilities. Here we are mixing our basic application features, such as the welcome component, with our product features, such as the product components, with our shared features, such as the star component. As we add more feature sets to this application, such as customer management, invoicing, and so on, this is only going to get harder to manage. So let's reorganize and refactor to break this into multiple Angular modules. The first thing we want to do is extract some of these pieces into feature sets. We can then create a feature module for each feature set. Using feature modules helps us partition our application into logical groupings with separate concerns. Our first step is to define a new feature module. Creating a feature module involves defining a new module file, product module in this example, and reorganizing the pieces of the application so that all of the associated feature pieces and everything they need are here in this module. In the declarations array of the feature module, we add the appropriate components that provide the features for the application. In this example, we add the product list component and product detail component. Then, as we did with the box example at the beginning of this course module, we start to look at what each component's template needs. In this example, the product list component uses the pipe, so we need that. And both the product list and product detail components use the star component, so we'll need that here as well. But that's not enough. The product list component uses NgModule and ng-for, and both components use ngIf and routing. How do we get that? We import these needed capabilities from other Angular modules. Our product components use routing, so we import the system router module. The product list component uses NgModule, so we import the system forms module. And we need ng-for and ngIf. So do we pull in the system browser module? Nope. The browser module should only be imported into the root application module, AppModule. Instead, we import the system common module. The common module exposes the ng-for and ngIf directives. Not surprisingly, the browser module itself actually imports and exports the common module, which is why we have access to ng-for and ngIf when we import browser module in our app module. Our feature module is looking pretty good here, but now that we've removed these features from the root application module, how will the application find all of these features? What's that? Imports array, did you say? That's correct. We need to import the product module into the app module. That extends the app module with the product module features. Want to try this out? In this demo, we'll build a feature module for our product features. We are back in the sample application. Here is our app module. Let's create a new feature module for our product feature. Want to try generating it with the Angular CLI? We open the integrated terminal. Let's stop the compiler because we'll want to restart after making these significant changes. Clear the console and type ng for the Angular CLI, G for generate, M for module, and the name of our module. Since we are creating the product module, we want it in the products folder, so products/product. That's all that's required. But by default, Angular will create a new folder for this module because it rightly assumes that we'll create the module when we define the feature and the feature folder. But we already have the products folder, so we'll use the --flat option. and we want to import this module into the AppModule to pull in its functionality. So we use the -m flag, specifying the module name. Press Enter, and we see that the CLI created the module. It also updated our AppModule. We can see that here. It added product module to our imports array. Yay! Let's open the new product module. The CLI already created the class with the NgModule Decorator and the required import statements. My version of the CLI created some extra empty lines. I'll delete them. Since this module is for our product features, in the declarations array, we add the product list component, product detail component, convert to spaces pipe, and start component. Now we can remove these declarations from the app module. Going back to our product module, we can see that the CLI already included common module here, since we need that in every feature module. We'll add the forms module and router module. Now we can remove the forms module from the app module. When we added the router module to the imports array in the app module, we called forRoute to pass in the configured routes for our route component. Now that we are adding the router module to the imports array of a feature module, we don't call forRoute. Rather, we call forChild, and there we pass in the routes related to products. Let's cut the product routes from the app module and paste them here in our product module, and add the import statement for the product detail guard. Recall that the router module registers the router service provider, declares the router directives, and exposes our configured routes. But as we've discussed previously, we never want to register a service more than once. So when we use forRoute to pass in our configured routes, the router module knows to register the router service provider. When we use forChild, as we did here, the router module knows not to re-register the router service. Going back to the app module, let's delete our unused import statements. We can easily identify them as they are grayed out. Do you think our application will run? Open the terminal and restart the compiler with npm start. Click the product list option, and our application still works as expected. Yay! So we now have our first working feature module. But let's think about this for a moment. As we build our application, we'll build more features. Each logical set of features will have their own feature module, and each feature module will most likely need the common module for common directives such as ng-for and ng-if, the forms module for ngModule and two-way binding, and we may have other features that want to reuse our star component. Do we really want to repeat all of this in each feature module? There has to be a better way. Yep, we can define a shared module. The purpose of a shared module is to organize a set of commonly used pieces into one module and export those pieces so they are available to any module that imports the shared module. This allows us to selectively aggregate our reusable components and any external modules and re-export them in a consolidated convenience module. Creating a shared module involves defining a new module file, shared module in this example, and reorganizing the pieces of the application so that the shared pieces are here in this module. First, we add the components, directives, and pipes that we want to share throughout our application to the declarations array. In this example, we only want to add the star component. Then we add to the imports array anything needed by the templates associated with this shared module's components. In this example, we import the common module because our star component template may need it. We don't import forms module because we don't need it here. If our star component did use two-way binding, or we added another component here that did, we'd need to import forms module as well. We then need to export everything that we want to share. The exports array defines what this Angular module shares with any module that imports it. We export the star component. That way it is available to the components in any module that imports the shared module. We re-export the Common module and Forms module, so their directives and other features are available to any module that imports the shared module. And notice here that we can export something without importing it first. A reminder that in this context, when I say export something, I'm referring to adding that something to the exports array of the NgModule Decorator. And when I say import something, I'm referring to adding that something to the imports array of the NgModule Decorator. To use this shared module, we import it into every feature module that needs the shared capabilities, such as our product module. Let's give this a try. We want to build a shared module, and we'll again use the CLI. Do you recall the correct CLI command to generate a module? We type ng for the Angular CLI, G for generate, M for module, and the name of our module. Since we are creating the shared module, we want it in the shared folder, so shared/shared. We already have the shared folder in place, so we'll specify the --flat option. That way the CLI won't create another folder. And we want to import this module into the product module to pull in its functionality. So we use the -m flag, specifying the module path and name. Press Enter, and we see that the CLI creates the shared module, and it updates our product module. We can see that here. It added shared module to our imports array. Let's open the new shared module, and I'll again delete the extra empty lines. The CLI already created the class with the NgModule Decorator and the required import statements, and it included Common module in the imports array here. Now, what did we want to share? Well, we want to share the star component, so we add that to the declarations array here. To share the star component, we need to export it. Let's add an exports array and export the star component. There's a few more things that we want to share. So we don't have to import them into every feature module, we'll add Common module and Forms module to the exports array. If there were other modules we wanted to share, such as Reactive Forms module or Material Design, we could add them here as well. We could also share the Convert to Spaces pipe. I'll leave that up to you to add here if you wish. Now we can remove the star component, Common module, and Forms module from the product module, along with their associated import statements, since these are now already accessible from the imported shared module. Are we good to go? Yep, our application comes up as it did before. Looking back at our code, notice now that our feature module, product module, only contains product pieces and the shared module. And the shared module is clean, only including the pieces we want to share. We can reuse the shared module in any future feature modules as we add functionality to our application. We now know that every application has a root application module that is by convention called AppModule. The main purpose of the AppModule is to orchestrate the application as a whole. And now that we've removed the feature and shared pieces from this module, its purpose is easier to see. Let's take another look. We've reduced the code in AppModule such that it now fits on one page. The AppModule normally imports Browser module. This is the module that every browser application must import. Browser module registers critical application service providers. It also imports and exports Common module, which declares and exports directives such as ngIf and ng-for. These directives are then available to any of the AppModule's component templates. We are also importing HTTP client module to register the Angular HTTP client service provider. We import router module and call for route, passing in the configured routes for the root of the application. Here we configure our default route and any wildcard routes. Then we import each feature module. In this example, we have only one feature module, product module. The declarations array identifies the list of components that belong to this module, In this example, the root component, app component, and the application's welcome component are declared here. The bootstrap array identifies the root component, app component, as the bootstrap component. When Angular launches the application, it loads this component and displays its template. Now let's finish up this course module with some checklists and a summary. When creating an Angular module, we build a class and decorate it with the NgModule Decorator. The NgModule metadata is comprised of a set of arrays. The declarations array of the NgModule Decorator declares the components that belong to this module. This array contains the list of components owned by the module. Declare each component of the application in one and only one module, and declare the custom directives and pipes used by the declared components, unless they are already available from an imported module. The imports array of the NgModule Decorator imports the modules that this module needs. This includes modules that provide components, directives, and pipes needed by templates associated with components declared in the module. For example, Common Module and Forms Module, or our custom shared module. The imports array also includes modules that provide system or third-party services, such as HTTP Client Module. These modules are often only imported into the AppModule, so the services are only registered one time. And we pull in features from our feature modules by adding them to the imports array as well. We use the exports array of the NgModule Decorator to define the pieces we want to share. This includes components, directives, and pipes, such as our Start component, and other modules, such as Common Module or Forms Module. The exports array is often only used by shared modules. Lastly, the bootstrap array defines what the index.html file needs to start up the application. This is the component with the selector used in the index.html file. The bootstrap array is normally only used by the app module. If you are building a small application, such as the sample application we've created in this course, you may only need the one root application module, as shown here. But as your application grows, you'll want to refactor into feature modules and shared modules, like this. Here we organized our application into multiple modules. We have our feature module, product module, that encapsulates all of the product features. There will be more feature modules as our application grows. We have our shared module that shares commonly used components, directives, and pipes with any module that imports it. Currently, we import it into the product module. As we build more feature modules, we'll import it into them as well. And we have our app module that orchestrates the application. Each feature module is added to the app module's imports array to extend the application with those features. Next up, let's take a peek at more of the features of the Angular CLI.